Hello, welcome back to Geometry with Mr. Freena. Today we discuss similar polygons. Now, similar polygons are polygons with the same shape but different size. Alright, now if you remember congruent polygons, they have both the same size and shape. So now similar polygons are the same shape but different size. I like to use the comparison of a Matchbox car. Matchbox car is identical to the actual car but just scaled down. So it has the same shape but it's a different size. Now the symbol for similar polygons we use is the little tilde. Alright, and when we look at it, we might say triangle ABC is similar to triangle, DEF. So anytime you see that symbol, it means the polygons are similar. Now, if polygons have the same shape but different size, alright, two things must happen if they are similar. One, the corresponding angles will be congruent, alright, and that's what gives it the same shape. Now the different size, although they're not congruent, the size excuse me, the sides aren't congruent, what we say is the corresponding sides are proportional. And what that means is all the ratios are equal. Okay? So in order to show if two polygons are similar, we'll have to show all corresponding angles congruent, all corresponding sides proportional. Similarity ratio is basically the ratio of the corresponding sides. Alright, and you'll also see the similarity ratio written as a scale factor. Okay? Now, just like congruent triangles back in first semester, when we write a similarity statement, you must match up the corresponding vertices. Okay, and this will be critical when we get to the next section on similar triangles. Okay, let's look at a couple of examples. Alright, determine whether triangles are similar. If they are, write a similarity statement. Now, when we look at it, to show that these are similar, we have to show corresponding angles congruent. So, when we look at angles, we know angle A is congruent to angle F. That's one pair of angles. Angle B is congruent to angle E. And then we know angle C is congruent to angle D. So right now we're able to show corresponding angles congruent, so we know it has the same shape. But now we have to look at the sides. And we need to determine if the sides are proportional. So what we do is we match them up. AB corresponds to DE. Okay? So AB to, actually it corresponds to EF. So AB to EF equals BC to ED, which equals AC to DF. So what we're doing is we're writing all the ratios in terms of their sides. Now if we put the lengths in there, that would give us 15 over 20 equals 12 over 16, which equals 18 over 24. Now, although it doesn't look like these ratios are equal right now, one thing you can do is you can divide them in your calculator and get the decimal values to see if they're equal, or you can reduce the fractions. Both of these can be divided by 5, so we get 3 to 4 equals. Both of these can be divided by 4, 3 to 4 both of these can be divided by 6 to give us 3 to 4. Are the ratios of the corresponding sides equal? Yes. Therefore, these triangles are similar. So when we write our triangle similarity statement, right, what we have to make sure we do is match up the corresponding vertices. And after writing the congruent angles, I already did that. Triangle ABC is similar to A was corresponding to F, B to E, and C to D. Now, what is the similarity ratio or the scale factor? Well, what was the ratio of the corresponding sides? 3 to 4. Okay, and these are similar triangles. Now here, if ABCD is similar to EFGH, complete each statement. Well guys, just like congruent triangles, we can either use the diagram or we can use the similarity statement. So, we know the measure of angle E and A go together, so that would be 53. Okay, so we know E corresponds to A. So angle E is congruent to angle A, so angle E is going to be 53 degrees. We know B corresponds to F, so we know angle B is congruent to angle F, so angle F is 127, so angle B is 127 degrees. Now, AB to EF is equal to AD to, when I look at the similarity statement, AD goes with EH. Therefore, AB to EF goes AD to EH. Then, GH to CD equals FG to BC. Alright, and those are the statements you need. Here, are the polygons similar? If they are, write a similarity statement and give the similarity ratio. So, let's just look at it. First, we'll look at the angles. Alright? We know right now that A and C are both 110. What could I do to figure out these two angles? Well, all three angles have to add up to 360. So 360 minus 110 minus 110, right, will give me 140. Which makes that 70, and that 70. And if I look at this, 360, minus 70 minus 70 gives me 220, which then gives me, divided by 2, 110 and 110. So when I look at the corresponding angles now, you have angle A is congruent to angle F. You have angle C is congruent to angle H. Then angle B is congruent to angle F. Angle E. And then angle D is congruent to angle G. So right now we have all corresponding angles congruent. So now when I look at the sides, all of the sides, if you think about it, this is a rhombus, this is a rhombus, so all of the ratios will be 8 to 10, which reduces to 4 to 5. So all my angles are congruent and all my corresponding sides are proportional. Therefore, these are similar. So A, B, C, D is similar to F, E, H, G. And the similarity ratio would equal 4 to 5. Okay? So in your homework, you do have to show all the corresponding angles that are congruent and all the ratios to be equal. You must show that. Now next, how do we use this? Well, if I want to find the value of x, they already told me in this example that these polygons are similar. Okay? So, when I look at it, if I'm looking for s, or for x, I know TS goes with NO. So right now I can write a ratio of 2 to x, because those sides correspond, equals, if I look at the two other sides I know LM, and I know that corresponds to QR. So I set that ratio up in the same order. If I put this in the numerator, alright, and this in the denominator, it must stay that way. So 2 over x equals 5 over 6. Now I can go ahead and solve for x. Solve the proportion by cross multiplying. 5x equals 12. X equals 12 fifths. And I prefer it to be left in improper fraction form. Okay, next. Here we have a couple of variables. What I would do here right away is highlight the corresponding sides. So you got 2 arcs, no arcs, 2 arcs, no arcs. Here, you have no arc, no arc. Right there, those correspond. Then, no arc to 1 arc, no arc to 1 arc. Then finally, 2 arcs to 1 arc, 2 arcs to 1 arc. So I know I could write all of these ratios up. So my similarity ratio right away, if I look, the two sides I know correspond to each other and I know their lengths are the yellow segments. So I'm going to write that as 5 to 10, but that could also reduce to 1/2. So I go ahead and I start writing, if I want to find z, z corresponds to 15. Z to 15 equals 1 to 2. When I cross multiply, 2z equals 15. Z equals 15 halves, or 7.5. If I want to find y, I know y corresponds to 35 equals 1 to 2. So 2y equals 35. Y equals 35 over 2, which is 17.5. Now if I'm looking for x, x corresponds with 10. But remember, you got to keep the ratios in the same order. So we say 10 to x, because I put this one on top, this one on bottom, equals 1 to 2. When I cross multiply here, I get x equals 20. And those are the values of the variables. So the key here, guys, is finding the similarity ratio. What should the ratio of all the sides be? Then set up your proportions like we did here, here, and here, and then solve for the variable by cross multiplying. Now, so here we want to find the perimeter of each of these figures. So just by congruent sides, that's 8 and that's going to be 4, because these go together, these go together. Now, in order to find the perimeter of the other one, we have to find all the sides. Well, we know RS corresponds to CD, right? So we know the similarity ratio or scale factor is going to be 4 to 3. So to find the perimeter of the other object, we have to find QR first. Now if we look at QR, QR corresponds with BC. So we basically set the proportion up. 4 to 3 equals BC has a length of 8 to QR. When I cross multiply and solve, 4QR equals 24 and QR equals 6. Alright, so we have QR now is 6, that's 6. Then if I look at the last one, 4 to 3 equals ED to ST, and ED has a length of 6. So when I cross multiply, 4ST equals 18, ST equals 2.5. Now I can go ahead and find the perimeter. Alright, because we're running out of time, I'm going to do the last setup. When we're doing these, okay, it is important to again match up the corresponding vertices. Similarity ratio would be 4 to JM corresponds with QT. So